Hello there. How are you doing today? I hope good. All right. So today we're looking at a very interesting problem. Um, the problem we're going to be looking at is the boat and the ambulance problem. The boat and the ambulance problem. Now, how exactly are we going to deal with a situation like this? It's quite interesting. Let's go ahead and read the whole thing. So we'll have an overview of what the question is talking about. Now, the question here says, you are the captain of a ship and one of your passengers has been injured. Now this is your ship here. Your ship is 30 miles from a point. This is your ship, is 30 miles from this point, as you can see here. 30 miles from a point that is 60 miles downshore from a hospital. This is our hospital here. So let's not move beyond the problem here. This is our hospital, and then we're told that the ship is 60 miles downshore. So that is from here to here is 60 miles downshore from hospital, and then you must order an ambulance to meet your ship at any point along a road. Now since this is the road here, so since we do not know the point, so we just chose B arbitrarily. So this is the point where you want to meet. So it says to meet your ship at any point along a road that runs parallel to the shoreline, you would like to meet the ambulance at a point that will get your passenger to the hospital in the shortest possible time. So you have chosen this point here arbitrarily. So since you do not know where this point is, let's call from here to here. Let's call this X. So from here to here is X, and then from here to here is going to be 60 minus X, since the total distance from A to H is 60. So what we want to do is, it says you would like to meet the ambulance at a point that will get your passenger to the hospital in the shortest possible time. Now suppose that your boat travels at a rate of 20 meters per hour. So the speed of the boat is 20 meters per hour, and the speed of the ambulance is 50 meters per hour. The speed of the ambulance is 50 meters per hour. They said describe the location of the point where the ambulance should be met to minimize the passenger's travel time to the hospital. So let's look at the problem here. You have a boat, this is your ship here, and then your destination is to go to the hospital here. To make the whole thing work faster, you told the driver at the hospital to meet at a particular point, and then to make it faster for you, you can't go through this path here. You have to go through a straight path, so that you guys are going to meet so that the driver of the boat and the driver of the hospital would meet at a particular point, and then at this point here, the driver is going to ship the passenger who has been injured to the hospital in the shortest period of time. So what we are going to do is, we are told to describe the location of the point where the ambulance should be met to minimize the passenger's travel time to the hospital. So let's assume the time taken for the driver at the hospital to reach this point. Let's call that time, let's call it T1. We'll call it T1. While the time taken for the driver at the boat to reach this point here, let's call that point, let's call it T2. So that implies that the total time taken for the passenger to move from the boat straight down to the hospital is going to be T, which is equal to T1 plus T2. So this is the total time taken. Now we are told to minimize the time. Alright, we're going to pick each of this scenario one by each. So let's first consider the first scenario here, which is the scenario of the hospital, the driver of the hospital reaching this point B. So that's the first scenario we are considering. So let's call that 1. So the driver of the boat, so let's say this is point B here, and then this is the hospital here, which we are going to call H. So this is the line here, and we are told from here to here is 60 minus X. 60 minus X miles. 60 minus X miles. Now the passenger here, or the driver here that is driving a car, he has to reach this point here within the shortest period of time. That's the shortest possible time. And it has to travel through 60 minus x miles. Now, according to what we know that the speed of the ambulance is 50 miles per hour. So the speed of the ambulance, so this is the ambulance, this is the ambulance here, so don't mind my drawing. It looks a little, so this is the ambulance. It has the siren here. So it's doing way until it gets here. So we are told that the speed of the ambulance is 50 miles. So 50 miles in 1 hour. So if this is the speed and it has to go through 60 minus x miles, so the time taken, that 60 minus x miles, would have to go, so we'll cross multiply. So if 50 miles goes in 1 hour, then 60 minus x miles will go in 60 minus x times 1, which is 60 minus x divided by 50. So the time taken based on the speed we are given for the ambulance to reach this point B is going to be 60 minus x divided by 50. So therefore I found my T1. So my T1 is 60 minus x divided by 50 hours. So this is my T1. So let me go ahead and find T2, which is the second scenario that I'm going to consider. So my T2, let me sketch this triangle out. So the triangle we are given is this. So this is my boat. This is A, while this is B. This is a right triangle. Now, according to what we are told, from here we know that from here to here is 30, and from here to here is x. So let's assume from here to here, that's from the boat to B. Let's call that point, let's call it y. So my aim is I want to find the distance between the boat and the point where the driver of the boat is going to meet the ambulance that moves from the hospital there. Now, to do this, I have to use something they call the Pythagorean theorem. I'm using the Pythagorean theorem because this is a right angle triangle. And what does the Pythagorean theorem, what does it say? It says that the square of the hypotenuse, that's one facing here, that's y squared, equals the sum of the squares of the other two sides of the right angle triangle, that is 30 squared plus x squared. Now 30 squared is 900 plus x squared. So if this is this, so if y squared is this, so y is just going to be the square root of 900 plus x squared. So that implies that the distance from the boat to B is 900 plus x squared. It doesn't stop there. We are told that the speed of the boat is 20 miles per hour. So we are told that the speed of the boat is 20 miles in 1 hour. Now if the miles, that's from here to here, that's the distance from here to here, which we have gotten here, is root 90 plus x squared miles. So this is root 900 plus x squared miles. So we know that 20 miles is to 1 hour. So how then do we find 900 plus x squared miles? So we cross multiply like we did. So this time is 1. That is root 900 plus x squared divided by 20. So this is going to be the time taken for the driver of the boat to reach this point here. So I already found my T2. So this is my T2 as 900 squared. So my T2 is 900 plus x squared divided by 50. So the total time taken, so do not forget, we are told to minimize the passenger's travel time. So the information is to minimize the time. So I have to first find the time. So when I find the time, I then minimize it. So the time is T1 plus T2. So that is my time is T1 plus T2. And our T1, like we obtained above, is this, which is 60 minus x 60 minus x divided by 50 plus my T2, which is the root of 900 plus x squared divided by 20. So this is the total time taken that the whole process is going to go through. So our aim is to find the value of x, that is the x that is going to minimize this whole function here. So in other words, our function here, the function we are given, or the function that we have, is t of x. Our t of x is 60 minus x divided by 50 plus the root of 900 plus x squared divided by 20. So our aim is to minimize t of x. So the problem is to minimize t of x. So how then do I minimize t of x? So let's go and use our calculator to do that, our T189 calculator. So what we have here is let's just pull this to this side. Behaves a little funny sometimes. Okay, so we have 60 minus x divided by 50. So let's punch our calculator. So we go to y equals to, that's the y editor. So punch this. So we're in our y editor. Let's punch enter. So the first one we have here is 60 minus x divided by 50. So we open bracket, 60 minus x, our x, divided by 50, then plus the root of 900 as the root. Where's the root? Oh, the second function, the root of 900 plus x squared, 900 plus x to the power 2. So we close bracket, divided by 20, and then we punch enter. So this is our function here, 60 minus x divided by 50 plus root 900 plus x squared divided by 20. So we want to minimize this function. How do we minimize the function? Let's plot the graph. So plot the graph. So the graph is here, f3. So this is the graph of the function here. You can see. Now looking at this graph here, you'd see that this point here happens to be the minimum point of this whole graph. You can see the graph has a form of a parabola that opens up. You can see that's the parabola here. So now how then do I find the minimum point on this graph? So I'm going to use, so you have f5 is math, like you can see here. So we punch f5, so then we scroll down to minimum is 3, so we punch 3. So when we punch 3, so what it's saying is it needs the lower bound and the upper bound. That is, where is the minimum, from which point to which point do we have the minimum point? So looking at the graph here, the minimum lies between this point here and this point here. So I'm going to push this cursor here, since the minimum lies at this point. So I'm going to choose there as my lower bound. So we have lower bound, then is demanding for the upper bound. So we go straight down and then choose an upper bound. So yes, I can choose here as my upper bound. I punch enter and then I wait for the calculator to give me my minimum point. Yes, so it tells me that this is the exact position of the minimum point, and that corresponds to x equals 13.0931. So let's go back here. So my x, so the minimum, that's the x that minimizes this function, is 13.09 miles. So what the question says is, describe the location of the point where the ambulance should be met to minimize the passenger's travel time. Now if my x, so since the x we obtained, as the x we obtained is x equals 13.09, then the distance from here to here, which is 60 minus x, 60 minus x, which is 13.09, and that happens to be 46.9 miles. So in other words, the ambulance should be met at 46.9 miles from the hospital, and then that completes the problem.